welcome. Good morning, good afternoon, good evening, depending on where you are. Thank you for joining us for this next session at IIoT World Energy Day 2026, Enforcing Compliance Upstream for AI-Ready Operations, sponsored today by Adlib Software. So first off, as usual, please feel free to tell us who you are, where you are in the chat, just so we get a feel for who's joining us. And I'm going to start off with a couple of bits of housekeeping. As I'm sure we all know, it's an hour-long session. I'm going to introduce the topic. I'm going to introduce our wonderful guest speakers, and we're going to get lots of insight from them, but we also will do our best to leave some time for questions at the end from you, our audience. We love getting questions, and we know you like asking them, and we do. One of the the differentiators for us in these kind of events is that we are live and we are taking your questions live, and we'll try and get to as many of them as we can at the end. And if we don't get to your question, we will do our best to get you a response after the event as well. So please put your questions in the Q&A tool within the platform. Don't put them in the chat. If you put them in the chat, I might miss them. So use the Q&A tool, that's what it's there for, and you will make our lives easier and you'll have a better chance of getting your question answered as well. All right, so time to focus on the session. Most energy enterprises have already invested in historians, ALM, ALIM, EHS platforms, content repositories, and some have also started making major investments in AI, of course. And yet there's still a reliance on people to manually clean, transform, and validate operational documents as they move between systems. And this is where errors can creep in, cycle time stretch, and compliance exposure grows, which is our topic for today. So we're going to be taking a deep dive into all of that and how to enforce compliance upstream in that kind of environment. And to do that, to help us do that, we have three very special guests who I'd like to introduce you to now. First of all, we have Chris Huff, CEO of Adlib Software, who's our sponsor for today. He's a growth-focused tech and SaaS executive with a proven track record in scaling enterprise software companies backed by private equity and venture capital. He's known for building strong teams and driving value through operational efficiency, revenue growth, and product innovation. And prior to joining Adlib, he was CEO at Base64.ai and Chief Strategy and Growth Officer at Tungsten Automation. He also co-led Deloitte's US public sector intelligent automation practice. And before all of that, he was a major in the US Marine Corps. So don't mess with Chris would be my advice. Thank you very much for joining us, Chris. Then we have Anthony Vigliotti, who is CPO, also at Adlib Software. Anthony has over 20 years of experience in business workflow and intelligent document processing with prior roles at Kofax, Nuance, Notable Solutions, and Xerox. In those roles, he developed deep expertise in product management, alliance and partner management, and product development. And he has a bachelor's degree in mechanical engineering and a master's degree in information technology, both from Rochester Institute of Technology. Thank you very much for joining us, Anthony. Great to see you again. And then we have Luke Small, Chief Product and Strategy Officer at GE Vernova. He's an industry go-to-market executive with over 20 years of experience working in digital industry, applying strategic thinking to new go-to-market and growth strategies. He successfully spearheaded large multinational digital transformation projects for Fortune 100 companies, and his passion is creating new business models across various verticals in the discrete and process space using IoT edge sensors, big data, and advanced analytics. And he advises global and early-stage firms focusing on digital strategy, sales marketing, go-to-market planning, leveraging all his prior executive experience at G Digital, Emerson, Flashpoint, and his own firm, Chakra. Finally, and very much the least important person in the room is myself, Hamish McKenzie. I'm an IIoT World Advisory Board member. I'm also an ex-IDC analyst, and I've been running my consultancy practice here in Munich, Germany for the last 25 years. I'm also, like Luke, a go-to-market guy. So I advise technology companies in various aspects of their own go-to-market and revenue operations strategies. I'm pretty sure I'm the only Hamish McKenzie in Munich on LinkedIn, so please do look me up on there. Feel free to connect. And with all of that said, I think it's about time we got into the meat of the session, and we've got a lot of things to talk about. So as always with these sessions, I like to start off with a bit of context. And so I'd like to start off with you, Chris. At the board and executive level, obviously AI is being pushed very aggressively across the energy sector. But we're finding that a lot of organizations are still struggling to operationalize AI at scale. And prove the value. And from your vantage point, where do you see the biggest gap then between AI ambition and the operational reality in energy enterprises?
Great question right out of the gate. First, great to be here with you again, Hamish, and looking forward to a great conversation with Luke and Anthony. From my vantage point, I believe the biggest gap between AI ambition and operational reality isn't the lack of ambition or even the compute power.
Hmm.
I think it's a trust gap, and we believe at Adlib that that's really fueled by unstructured data that's sort of stuck in documents. Some call this dark matter. And specifically in the energy sector, you've got leading companies, and Hamish and Luke being like go-to-market experts that you are, you probably see this on a daily basis where these companies, forward-leaning companies, they're building like these Ferrari AI models, highly sophisticated, autonomous agents, but often fueling them with like low-octane data because they're only fueling them typically with standardized structured data, which is maybe 20-25% of like the total data pool. So it's really low octane data. It's not that knowledgeable in terms of like what's really going on with the organization. So what I find is like most organizations are trying to point these models at decades of unverified PDFs, handwritten maintenance logs, maybe some disconnected engineering records. And when the AI actually encounters that dark data of unstructured content, the AI simply just performs poorly. We would say maybe it hallucinates, doesn't get it right, but it's not accurate. And in highly regulated industries like energy, that's just simply unacceptable. So you end up seeing AI projects get sort of stuck in this experimental purgatory, as opposed to like scaling and truly providing ROI to the organization. So that's what we're seeing is that the gap is really this absence of a, let's call it like a governed accuracy layer that transforms this raw content into what we would call like a document of record that AI can actually reason against with certainty. And that's primarily where Adlib plays.
Okay, fantastic. And I love your example there of the Ferrari. People don't realize that if you are lucky enough to spend $1 million on a Ferrari or a Lamborghini, if you put the rubbish fuel in it, you will destroy it. It will break. So don't do that, and don't rely on
And
spending 25%
enterprises
of the data.
today, there's a couple things that's driving like the Ferrari build. And I don't know if they particularly started out wanting the Ferrari. It was almost forced on them because this AI innovation wave, it's really coming down from boards and CEOs. So they're investing large sums of programmed funding into this experiment. So you almost have to go straight to the Ferrari because you've got so much funding for it. And then at the same time, we're starting to see even stuck in experimental and not really scale, we're starting to see the compute cost based on the token usage go through the roof. Just like 20 years ago, it was cloud compute, and how that was sold initially as like this is a more optimized and efficient way of doing your workloads. And then you started to get the cloud service provider bills and you're like, whoa, we have to optimize this. I think enterprises are realizing very, very quickly that they need to send the right work through compute and these AI models as opposed to like all of the work. And that's primarily driven by the token optimization efforts that we see underway right now.
Yeah, absolutely. All right, Luke, I want to come to you now. So, I mean, we're kind of, this kind of all started over the last 20, 30 years of talk about big data, but we don't really hear about the 4 V's of big data anymore, by which I mean volume, velocity, variety, and veracity, of course. And is the impact of AI and LLMs, is that still a big data problem or not? And do the 4 V's, do we need to kind of reinvent them somehow? Or should we not be questioning them? What's your view on that?
Great question, Hamish. Thank you, and thank you for having me on. It's great to get Vernova in the middle of this conversation. So excited to learn more from the group as well. So I'm also glad you reminded me what the 4 V's stood for when you brought the question up, because I was going to have to scramble here on my other screen to Google them or chatbot them. But yeah, it's fascinating. I see this continued challenge, whether it's the 4 V's, whether it's garbage in, garbage out. The low octane data, low octane fuel in your Ferrari is a perfect analogy. Chris, I love that. But we seem to be forgetting that this is a evolution of technology. This is, to me, an abstraction of the existing stack we have. And the principles, the core fundamentals of computer science shouldn't go away. And I don't know if I have an answer for you today on, do we need to evolve the 4Vs? But I think I can answer, and this is what I talk about a lot with our customers, is that if we'd called large language models big language models, I think we would be having a much more pragmatic conversation. I think people forget this is a big data problem, exactly like Chris talked about, the foundational elements that you need in place to support a big data project, whether you're training the LLM and you can afford to do something as sophisticated as that, or you're using the LLM as a UX layer or something in between, the foundational data has got to be correct. And the other joke I make with more technical folks who maybe come from a computer science background or have done any basic coding course, we'd all remember the first thing you get to do is create Hello World, and you pop it up on your screen. And the number of RAG pilots where we're taking a maintenance manual, ragging it into an LLM, and summarizing that data and popping out an answer. Whether it's right or wrong, we don't really know. That's not even the 2026. That was the 2025 version of Hello World. That's all it is. And it's another grounding to me, and we just can't forget the foundational elements of computer science and the 4Vs of big data. I think absolutely we should relook at them, but I would say a core tenet of how we think about everything we're talking about today.
Okay, fantastic. Thank you for that. So we're going to start getting into the weeds in a minute. But before we do that, Paul, could you bring our first poll up, please? We've got 2 or 3 poll questions we want to bring up in this session. So there we go. What is the biggest barrier to scaling digital twin initiatives in your organization? And digital twins is what we're going to be talking about in a minute. So I'll just give you 10 or 20 seconds to get your answers in on that one. And then we'll have a look at the results in a minute. While we do that, Anthony, if I could kick off the kind of digital twin aspect of this. So obviously, as we were already talking about, Chris already mentioned, a huge amount of operational context still lives in documents. So and it's unstructured. How can organizations bring that unstructured content into the digital twin environment in a reliable way?
A great question. It's a pleasure being on the panel and seeing you once again. I really wish I could have had the answer to the poll question for this particular one. So we'll see if my...
Okay, so Paul, I can ask Paul if he can bring the
results up. We can test my skill here. See if I'm good at what we're saying here.
Here we go.
So from a digital twin perspective, it's a quite interesting topic. So when you think of digital twin, really it's around like visualizing, data that either comes from a sensor or some sort of asset. But as these digital twins are evolving, we're also asking them to do some pretty amazing things, like maybe optimize the asset, maybe to simulate like what if scenarios, maybe to predict the life cycle or service history of this particular asset. And the only way that those things actually can happen is if the system has context, right? It's the context like of the engineering intent of that asset. What did the designers intend? What is the ongoing service history for that particular asset? What are the documents from the vendor who actually built the asset? What does it say around its policies and procedures for maintaining and supporting that? And is it doing the work as intended? So really getting that context into the system in a reliable and accurate way is really the heart of the problem. So when we look at what we need to do in order to get the context in, it's not just about digitization. That's a relatively simple way, but in order to get this to work well, the formats need to be normalized and the metadata needs to be normalized as well. The data that we're pulling into these various systems that are supporting the digital twins, they need to be mapped to the appropriate fields so that the metadata is truly in the right place at the right time. In addition, you need to validate this data. It's a one thing of getting it out of the particular document, but there's numerous systems within the environment for which this data can be validated, whether it's from the historian context, so your asset management system, or from within the document itself. So I guess the point of the story here is if you have these digital twins and you're not setting the appropriate context in an accurate, reliable way, you really kind of only have like a partial twin. And you're really missing the engineering intent or the service history or the operational history to really drive that digital twin to be successful and as accurate as possible. So you'll learn more throughout the session as to how you may be able to normalize and extract and preserve this data. But those are the key problems as to how you get to a digital twin that's meaningful and impactful.
Okay, and quick feedback on the results that you see there on the screen. Is that what you would expect to see?
Yeah, I personally voted 33%. We normally see the 21%, the data quality and accuracy kind of creeping up. So I think, Chris, based on our history, that's normally 1. It seems to be, if math is right, 3 in this case. So it's a slight deviation from normal, but not surprising.
Okay, fantastic. All right, thank you for that. So, Chris, if I can come back to you, a lot of organizations try to fix data quality downstream inside analytics platforms and AI models, but we're focusing here on trying to enforce compliance upstream. So in that context, why is document quality and consistency earlier in the process so important?
Yeah, and what's interesting, so tying this question to the results that we just saw and to the surprise that Anthony sort of identified, where data standardization, that typically hasn't been number 1. It is interesting to see it now leading the pack. And I think, hypothesis only, I think a reason for that is because we've used technologies over the last decade plus to really automate the ingestion and handling of standardized structured data, things like robotic process automation. We're able to handle that. But now they're going after the unstructured data because they know for these AI models to be worth their weight in gold, they need to fuel it with this unstructured data. So they're starting to go after it. And now they're realizing how difficult it is, which is why RPA and technologies like that never could handle it. And so in going after it, Anthony, I think that's why they're realizing, wow, one of the primary reasons why we've always sort of ignored this, not really went after it, is because there's a lot of work to actually standardize this data and get it to a level of quality to where you can actually meaningfully ingest it, make sense of it, and then take action on it. So it is interesting to see that. That's almost like a real-time shift that we're seeing. And I think it does punctuate the fact that there is a lot of AI investment going into trying to get to this really, really complex data. So I think people are doing their job. I also think that it's a fundamental shift in both capital allocation to drive ROI and basic architecture. If you think about historically, IT teams really tried to fix, this quality downstream, Hamish, as you were talking about, and they did it inside their core systems, inside their analytics platforms. Or today, they're actually trying to do it within their LLMs by scripting. And we know that now, that's still a challenge. But if you think about it, that's like trying to clean a river at the mouth instead of at the source. If you can continue to do it at the mouth, you're never going to clean that river. You have to start at the source. And so you start upstream as opposed to downstream. And that's what we do. So our enterprise customers, when addressing upstream governance, so how do we truly standardize and clean this data and take this dark matter data within documents and turn it into a data product that then you can fuel the AI models with, they're typically realizing about a 5 to 6 to 1 ROI versus downstream optimization, which is almost like Band-Aid fixes. You're not really going to get to the source of the problem. So our philosophy has always been upstream first. If you don't enforce the document quality, consistency, the compliance at the point of ingestion, you're simply scaling errors. And when you do ingest a document, what we do is we apply what we would call a governance shield immediately to the data. To Anthony's earlier point, normalizing the formats, extracting the facts with high fidelity pre-processing. and therefore are able to validate the provenance of the document and the data as it's flowing throughout your organization. And that's how I believe you really turn this dark matter data within highly complex documents into what we would say would be like audit-ready data products. And then Luke, to your point, like then you feed that into your, RAG models, your retrieval augmented generation. You're feeding it like a clean pipeline of validated data from the start, and therefore your AI becomes defensible.
Fantastic. All right, thank you. So obviously there's, as you pointed out, there's a lot of money being spent, but there's still a lot of manual work going on as well in terms of manually cleaning and validating documents. So Anthony, where do you see these breakdowns happening when it comes to real world operations? Anthony, I think you're on mute.
Yeah, it's a conversation that we have near daily with our customers. If you think about what's happened over time, as the technology has accelerated, there's been a lot of point solutions that were put in place along the way. And what we're attempting to do today is try to connect virtually the unconnected. So if you put in a solution for asset management, it was put in there for a certain reason, right? Obviously to manage your assets. If you put in something that is around CAD drawings and maintaining those and version control, obviously you have CAD documents as your source. If you're dealing with like historians, you're dealing with a large data set. But all of these systems have information that's like critical to helping each other, to helping the AI ecosystem live and thrive. So we really need to get to a point where you're able to hand off between many systems, just not one system. And I would argue that the handoff between the systems is where the large amount of the problems do occur. The types of documents that reside in these systems or data that resides in these systems are very, very different. You may have CAD files, you may have a large data set, you may have pictures, you may have Word documents. All of that is great from a content perspective, but unless you normalize it and standardize it in some way, it's really hard to get a repeatable, reliable process out. So one of the first breakdown areas is typically just around how do you ingest these disparate document data sources. Then, it's largely, you just can't absorb the source document. You have to get that document or data in such a way that it can be cleanly, reliably ingested by your AI or RAG pipelines. But if you do this in a way where you're modifying or manipulating the image in some way, or not getting a true pixel representation of that document, you obviously lose some fidelity there. You also have to maintain the metadata. So yes, the content within the document is important, but the metadata from its source is equally important because this helps you maintain the traceability and auditability from start to finish. So like a second breakdown might be actually how you transform this data and documents from disparate types to something that's reliably ingested by AI and RAG. Right. Then you have the handoffs between these systems themselves. So I just mentioned a few of the systems you may have put in place. There are many standards within the energy sector, don't get me wrong, but these standards are somehow inconsistent. So some rely on CSV or JSON or XML, or they have APIs. So you need to get to a point where you're able to reliably move this document data from point A to point B to point C in a way where you don't lose fidelity or auditability or trust. And then finally is this point around validation. And that typically is where humans get involved. And what we're trying to do here is enable like kind of the integration layer, but the integration layer is largely reliable on humans cleaning up the mess that I just explained. So you'll learn, as we go through the rest of maybe the Q&A today, that there's things that you can do to optimize the way to knock down these 4 breakdown points, which is ingestion, transformation, like a handoff between systems, and just how you validate data.
Okay, but so many organizations have already invested in things like OCR tools, in maybe data normalization as well, and in theory that should really help in terms of getting documents ready for analytics and AI. But I think your belief is that, or what you see is that sometimes they fall short, right? So and that's because the way that you need to prepare documents for analytics and AI is fundamentally different. So can you just talk a little bit about why and how it's different?
Yeah, absolutely. So if you're unfamiliar with Adlib, we are masters at OCR and content conversion. We support 300 different file types, and obviously are able to OCR every one of them. our first inclination was to throw the technology we have at the problem, right? And what we realized is it does help. It's a tool to solve some steps. But when you're looking at the overall system and the accuracy and the outputs of the overall system, it fell short. So Adlib found itself having to essentially partner and understand the root causes of these problems. And what we found was that there's two problem sets. One is there's an accuracy and trust problem set, which happens prior to the large language model or AI technology. I'll get to that in a minute. And then there's like a validation step. Okay, I got an answer from the AI or agent. What do I do to validate? So we found that we had to really invest in these areas. So yes, we OCR. Yes, we have tools to standardize, but really the more important part when dealing with AI is the document makeup itself. So when Adlib or somebody really is in tune with documents, we really look at objects. The way you process handwriting versus digital text is very different. The way you process a CAD drawing versus, say, a handwritten drawing is very different. So understanding like the makeup of a particular document and understanding the objects that make up a document, you have a much better opportunity to clean up that pipeline for those objects before you feed them into the large language model. So for us, like this pre-processing step, yeah, it's OCR, yeah, it has a little bit of file conversion, but more importantly, it's understanding the document down to its very DNA, and then prepping the large language model or agents to be most successful with those object types. Right, that's the first part of it. Mm-hmm. The second part of it is really once you have a response from the large language model, there's many ways that you should be able to validate that data, to remove that human where possible. You have many systems in place where that data can be measured against. There's scripting that you can do within the document or data pool to automate the validation that a human would normally do. So really, those are the steps that we're taking now. It's more on the pre-processing side and the post-processing side after the LLM to drive, the accuracy, the auditability, and the trust that the AI pipeline and the RAG pipelines require. So okay. OCR is an important step. File conversion is an important step, but that alone won't solve this pipeline problem.
Okay, fantastic. So Luke, we're going to be coming to you when we get onto agents in a minute. I just wanted to check in with you, see if there's anything else you want to add on those topics we just discussed there.
No, I think it's a great conversation, and it's great to even learn more about Adlib and the way you guys are thinking about getting that data ready. I think maybe for the second half, the piece I'd like to bring in is and I know we're focused on upstream, and that's the key foundation, but how do we put value as the North Star for where we land downstream? And then I think Chris touched on it earlier on ROI, but it's really with tokenization and the cost of these things, it's linking all the great foundational work that needs to happen with the North Star of value through TCO and really solid kind of systems thinking around that.
Yeah, absolutely. Okay, so we're going to be coming on to that in a second. Just before we move on to the next section, Paul, could you bring up our second poll? Because we'd like to get a feel for how confident people are that their operational documents are audit ready. So let's see what they say about that. I'll just give everyone 20 seconds to do that, and then we'll pull up the results and see if there's any more surprises.
And Hamish, while you're pulling that up, Luke, to your last point, and again, I know we're going to get to it in a little bit, but around cost, so downstream cost impacting like early investment, go forward decisions, we're actually building, and I think, Anthony, it's going to be out in our April release, basically a token cost calculator. And then how we can deflect, because again, not every object within a document needs to go through a high, expensive model. You can send stuff open source. You can do like basic OCR on some stuff that doesn't need to like incur additional cost. And so creating almost like a token deflection element, and then a token cost calculator to help enterprises better understand, given the problem that they're trying to solve for, what it's actually going to cost before they actually run it through the models, get the bill.
Yeah, that's a great development. All right, thank you, Chris. Paul, can you bring up the results of that poll, please? So here we go. 11%, only 11% very confident. Significant gaps for almost 2/3 of people. Does this reflect reality as far as you're all concerned? What you're seeing in the market?
Unfortunately, it does.
Yeah.
Yeah, and I think it reminds me of my manufacturing days and visiting a machine shop we'd recently acquired. And my job back then was a project engineer to digitize the work instructions for that plant, that machine shop. And I remember going into the plant manager's office and we asked for an example of one of the drawings they used to machine the parts that we were buying. And he had this beautiful filing cabinet, and he opened the filing cabinet, took out this pristine drawing and showed it to us and said, here, you guys can digitize this. I said, thank you very much. I said, can we maybe walk the shop floor when you have a few minutes as well today? He said, of course. And I remember being with my project manager and tapping him on the shoulder and finding the drawing that was under the machinist's desk, covered in fingerprints and oil and markups and pen.
Right.
I said, this is what we need to digitize. And up to this day, I call it the ISO filing cabinet. And we cannot go digitize or feed the LLMs with the ISO filing cabinet. That's not going to work.
Okay, very good point. Thank you for that. Real world examples are always the best. Okay, Paul, you can take those results away now. Thanks. So let's move on to the next section then. So, Chris, obviously, regulated industries like energy, decisions driven by AI need to be explainable and auditable. And this explainability was actually a topic in my last session an hour or two ago as well. So how should organizations think about provenance and defensibility for AI, especially when those decisions rely on those operational documents we're talking about?
Yeah. And Luke, that was a great story. The boots on the ground stories are always the best because at the end of the day, like those are the problems that we have to solve for. They're not anecdotal. And in energy, as we know, like black box AI is an absolute non-starter. If an autonomous agent suggests a maintenance shutdown, change in operational load based on a set of engineering records, that like the regulator and the exec team that's like behind this, like responsible for the plant, like they need to know why. They're not just flipping switches and killing the line based on an output that isn't sourced, that can't be trusted. So we believe, like I think most people do, that AI, for it to be operationalized, it has to be defensible. Meaning you need like a persistent, let's call it a provenance graph, right? I think for the last decade or so, it's been like knowledge graph. You almost need a provenance graph now to like mitigate the risk of AI outputs being hallucinations. So again, at Adlib, every time our platform extracts a fact or an AI agent like makes a decision, we basically generate, and Anthony can get to the technicals of it, but we call it basically like a decision receipt. It basically is able to provide linkage between an outcome of a model all the way back to like the source document that was used for that model to make the decision that it's made. And I think we would also admit, especially based on like the poll that we just saw in the results, that it's critical to trace specific data points back to the exact document, the data within, the paragraph that it sits within, and to the exact version of the document, knowing that many of, say, the technical manuals, Luke, that you had on that manufacturing floor, like there's multiple versions and there's change requests coming in on a daily basis. To be able to get to the exact version is complicated enough.
It's so true, Chris. And I love the black box. So one of the products that we have at Vernova is Smart Signal. And this has been delivering AI and ML-based outcomes in energy for, I mean, they were founded over 20 years ago. And we acquired them 14 years ago, maybe at this stage. And that technology, plus the technology we use at Vernova to monitor our full or a huge portion of our gas turbine fleet, the learning from that is this key human in the loop. And that you said it at the start of the call, start of the session, that trust factor. And I know from sitting in on calls where either our monitoring and diagnostics team at Vernova is calling a customer, or my smart signal managed service team is calling a customer about their broader fleet, not just their Vernova gas turbine. It's this debate, it's this rich conversation that happens between a reliability engineer in that control tower environment and somebody on the ground who's got their hands dirty and has to make a decision about, in a lot of cases, we're asking customers to turn off a power generating asset in the current market, which is wild. And for them to trust that decision, and I think feeding in some of those conversations to LLM could be really interesting. We're gearing up to release a prescriptive recommendations product based on all the history from those phone calls and cases. But that's where the magic happens. So I think you nailed it, Chris.
Yeah, I mean, it's almost like with this new AI innovation wave, we had gotten to a point right before that with some advanced automation of maintaining deterministic outcomes as opposed to probabilistic. And then with this new wave, we've sort of taken a step back. The outcomes of these AI models now are more probabilistic than deterministic. So it's how do we get the outputs of AI models to a deterministic point, so that way we can basically shift from I think the AI is right to I can prove the AI is right. Therefore, you can make the decisions based on the trust that you have in the outputs around the decisions that you were just alluding to, Luke, around like shutting down what would otherwise be revenue generating activities.
100%.
Okay, fantastic. Thank you. So, Anthony, your team talks about preparing documents of record that are safe to feed into analytics, RAG pipelines, generative AI. So let's get into the weeds a little bit. What does that pipeline actually look like from ingestion to validation? And what are the key checkpoints you have that ensure accuracy? I think once you've talked a little bit about that, you also want to show a little video.
Yes, we have a video that we can reinforce some of these points.
Yeah.
But one of the most immediate answers is, if you're dealing in a regulated industry or you have auditors that are constantly or regularly asking for information, it really pays to invest in some sort of performance, like conformance. So when we submit to the Atomic Energy Commission, they want their documents in a certain way. And that requires the normalization of documents and standard file types and where the headers and footers goes and the minimum size of fonts. And the reason why they do that is because when the Atomic Energy Commission gets that document, they know exactly what it is, what to do with it, know how to process it. There is a standard that was followed. And I would argue that that same standard or similar standard is required by your AI and RAG pipelines. Now, if you're very varying in the way that you submit documents to your AI pipeline, you're going to get varying results. So the first thing that we tend to do is just standardize the ingestion. So throughout today, we've already mentioned numerous systems that you may have in your environment, and they have different ways for which you feed and pull information to them. So one of the normalization methods is to just standardize in the way that documents come into an environment to a single point. In this case, the single point could be Adlib. And we do this in a dynamic real-time way. So it's not like batching documents and queuing documents that you do over time. It's truly part of the day-to-day business process, and it's happening in real time. All right, so the first step is just ingestion. Then you get to the point of normalization. And this is true. This is about getting to a common file type. But it's also about understanding, as I mentioned earlier, the objects that may live within your documents and standardizing on the way you present those to the AI technology of choice, how you set context, the file types that you send, the examples that you provide may vary depending on the object type that exists within a document you're attempting to process. Which brings you to number 3, and this is really all about driving extraction and accurate extraction at that. So normalization really is a precursor to getting to a set of attributes that you can reliably trust on. Now, when you're talking about this extraction, the extraction just doesn't end at the LLM providing some content or the AI providing content back. You need to align this metadata to the various business systems that require it. Sometimes you're going to need a JSON. Sometimes you're going to need a text file. Sometimes you're going to need, a CSV file. And each system may be varying in the schema that's required. And also the metadata tags may be different too. System A may call it customer name, where system B may customer NA. It may be abbreviated for some reason. All those things are important to understand as you're aligning your metadata. Then there's this fifth step, which is around validation, which is how you take the metadata and the data that you pulled from the document and really validate that this is data that you want to insert into your downstream line of business process. And if it's not, flag it so that you can correct the issues through an agent or correct the issues through a human, but that variable, incorrect, maybe suspect data should never move forward. And then finally is just like the ultimate delivery, which is the packaging and delivering that document of record, which is conformant, predictable, and reliable every time. So I don't know how we get to the video, but if we can pull up that video now.
Yeah, Paul, can you do that?
And my attempt here is not necessarily just to let the video run, but to kind of pause the video as we run through here to reinforce the points. So just to clarify, the demonstration here is not to say, hey, look, we extracted these values. It's to show the 5 or 6 points that I just mentioned. What you can see in this initial piece, it's not playing for me here. Okay, can someone hit play?
Paul, can you maybe do that?
Yeah.
Okay, great.
All right. So what you see here is a P&I document, and this has obviously various components and assets in that document. I wish I could pause it here, but you can't.
There we go.
Oh, perfect. Awesome. So you just saw the PNID document. This document has various symbols. The lines themselves are really important. A double line is very different than a single line, which is very different than a dashed line. The text underneath the various assets is very meaningful. The direction of arrows is upstream and downstream. So just the understanding of the symbology within the document. This is where we're doing a normalization. So where we're pulling out the individual objects, or at least identifying them, so that we have the opportunity to really set the stage for the AI technology to do the right thing with these individual objects. All right, what you're seeing now here is simply us using our ingestion process through, can someone start the video again, please? Through our API. And what we're going to do here is upload a CAD file. This CAD file is obviously going to be normalized to various file formats. What you're seeing here is us hinting so that we are prompting the large language model based on the object types so that it pulls out the appropriate values. And behind that, you can see this notion of an alias. Right? The alias is how we map this data to the various downstream systems. So as I mentioned, system A may have customer name and system E be customer NA. The alias is what points to that particular field. Okay. If we can start playing the video again, now we have the examples and the hinting it's all required. This is typically not the way that you would see you would interact with this, but you can see here we've been able to group. There's nodes within a diagram, there's valves within a diagram, there are things that are happening upstream, there's things that are happening downstream. And what Adlib is able to do is not only extract the value, but categorize it into the appropriate schemes for the PNID type document classes and put the right data into the appropriate locations. Now, not suggesting this is the way you would interact, but what you're about to see is the last part, which is the delivery part, where Adlib has now taken the data that was extracted after it's been validated and packaged it in CSV, in this case, JSON file, so that we can map that to the downstream records by the appropriate classes. So what we did is we took a rather complex PNID document. We're able to normalize it so that the LLMs could be accurate. We were able to validate that data and also separate the content type into the appropriate classes, format those classes into the appropriate file type for downstream delivery. All right, so this is just an example of the 6 things that we just shared with you, ingestion through delivery, and just examples of those 6 steps.
Okay.
Okay, so that's essentially how you might normalize a process from start to finish.
Fantastic. All right, great to see how it actually works. All right, thank you very much, Anthony. So Luke, with the recent news around Agentforce at Salesforce, what are and perhaps you could just, for anybody who hasn't, not aware of that, perhaps to very briefly explain what that news is. What are the AI lessons learned around where to focus your efforts? And is there a link between owning the workflow and winning the agentic game?
Yeah, thanks, Hamish. Great question. And I don't want to put my personal opinions up as what's really happened at Agentforce and Salesforce, but I think what I'd recommend is people kind of get curious on what's gone on there. And I saw great thought leadership from Salesforce back at reInvent, AWS's big Vegas conference, about 2 years ago. And it was pretty compelling to see them talk about agentic architecture 2.5 years ago. And the refocusing of their business around the importance of Slack versus just pure CRM, I think that's a really interesting lesson learned. And really the potential lesson learned that I think time will tell. To bring that back to something it's probably safer for me to talk about is the transformation by understanding your workflows and understanding your business that's happened at GE. Mm-hmm. So I'm a boomerang back to GE. I think 6 or 7 years gone, and was when I was leaving, GE's stock was $6 a share, and now I'm back, and GE Vernova's stock today is about $850 a share, and that's not an accident. And if you've watched, and there's now case studies coming out, there was a very good article recently in The Economist about the transformation that's been driven at GE, that by knowing what you're really good at and the workflows that you own, and I don't mean workflow in a technical perspective, I just mean that the jobs that people are doing, the tasks they're doing, the things that you're really, really good at. If you look at the systematic approach that Larry Culp initially brought in to GE, and now Scott Strazik is driving to get us to that phenomenal stock price, it's by focusing on what you're really, really good at. And then that lays the foundation for AI, whether that's what's now called traditional AI, for example, ML, or some of these newer areas. And where that's paying off for us is that thanks to really focusing on what we're good at, building standard work and operating rhythms to ensure that's being done in a focused way, and we're delivering customer value in a focused way every day, we can start to layer in very advanced robotics, autonomous inspection into the plants that we run for our customers and deliver net new outcomes, again, with this hyper focus on what we're really good at in support of that value to the market and to our customers. So I think that's really, there's going to be a number of case studies I expect in the coming years, really stemming back to what we used to call digital transformation, and now we call AI transformation, on what businesses are set up in a lean and mean way to start to adopt all of this new technology and be the innovators, be the big growth engines in this new world that's been driven by generative.
Okay, but so you're talking about systems level transformations essentially, and how do you think that will? I want to ask everybody now to start thinking a little bit more future oriented, and how you think this might evolve. So, can you talk a little bit about how you think that could evolve, either within GE or just generally in the market going forward?
Yeah, I think that's the right word, is system and systems level thinking. And the way I think about that is, do you know the ecosystem you play in? Inside of that ecosystem, do you know not your supply chain or your value chain? That's important. Do you know your customer's value chain? And looking at your customer's value chain, probably the intersection of your own supply chain and the ecosystem you play in, that's ultimately what creates value for you and your customers. And if you can understand that, that's the system as well. If you can understand that system, which is ultimately a value delivery system, right? You make a thing or you produce power and someone buys that.
Yeah.
Simple as that. Then you can start to reimagine that system in context of what's possible with modern technology. The current modern technology, the tech du jour is generative, that's evolving into agentic. But the fundamentals of business strategy, what allowed us get from that $6 a share to $850 a share, similar to my comment earlier on about computer science, the fundamentals of business strategy and a systems level approach apply more than ever. And I think you're seeing the companies emerging now that are primed for this next iteration of technology transformation.
All right, thank you. So let's, I want to finish off the discussion with Chris before we move on to answer a couple of quick questions. So Chris, can you perhaps talk a little bit about, obviously energy companies have incredibly complex environments, and they have accumulated all of these things, the documents we've been talking about, engineering drawings on the floor covered in oil, and all sorts of other documentation. How do you see that legacy information becoming part of the new world of modern AI-driven operations, and where do you see that going in the next few years?
Yeah, and this almost bookends nicely, because one of the opening questions I think Anthony had taken was around like digital twins.
Exactly.
How mirroring of an environment they are. And so I think that when we talk about like digital twins, we often focus on like, telemetry twin. So Luke had obviously, with his background, like real-time sensors, IoT data. But if you're thinking about like the knowledge twin, so the data that's used to provide the knowledge to this digital twin, you start to get into the documents like the P&ID that Anthony just stepped us through, inspection records, vendor specs. All of that is often left just sort of behind in this static, PDF graveyard. It just doesn't get picked up. So that digital twin isn't really a knowledgeable digital twin. It's almost like a surface level replica. And so based on like what you guys just saw Anthony step you through in terms of like how we use Adlib, we see these legacy documents as the DNA of this digital twin. And to bring what you would call like in the energy sector, like brownfield environments into the digital age, we don't just digitize them, but we create this pixel perfect representation of the document. And using this agentic IDP, intelligent document processing, we're able to like reach into decades old engineering drawings, exact specific attributes, whether it's a valve or a turbine. We can verify data against current maintenance logs. And I think by doing this, we turn what would otherwise be like a dumb document into a structured machine readable asset that creates the foundation for a digital twin to be knowledgeable. And I think this allows a company like GE Vernova and the transformation that Luke stepped us through to not just see what an asset is doing via the IoT sensors, but to understand the intent and the history of that asset via its documentation. And so that's the evolution that we hope to help the GE Vernovas of the world with, is not just like evolving, but doing it smartly by understanding sort of the treasure trove of documentation that they actually have in order to make, smarter bets on a go-forward basis.
All right, fantastic. Thank you very much for that, Chris. Paul, do you want to bring up the final poll? And if everyone can just give their answer to that, and that will be very useful for our panelists. So let's get into a couple of questions then before we finish. So I'm going to take a slight risk here, because just as in our last session, one thing we didn't really talk a lot about so far is security, but someone has asked a security relevant question. So Thomas Jones says, even with provenance breadcrumbs, prompts can be manipulated to drive negative impacts. What are your thoughts on command and control in separate channels from content? Similar to the SS7 protocol from telecom industry addressing a similar attack vector. So I don't know if any of you can address that specifically, or at least talk about that kind of manipulation security aspect in general. I certainly can't answer it, unfortunately.
Yeah, I mean, personally, I don't have like the technical response to it other than to acknowledge that it is an absolute consideration and concern.
Okay.
So as anybody is implementing these AI technologies and connecting these various disparate systems, security from start to finish needs to be considered. And as we do this quickly, as this innovation wave is happening, sometimes you may overlook security inadvertently and then find yourself in a situation. So It's a absolute right topic. I just don't know if we have the right skill set here to address it.
Okay.
Yeah, and I think that my common theme for today, cyber, how you think about cyber, how your CISO does. I don't know how CISOs sleep at night, frankly, but when they do sleep at night, what do they wake up in the morning thinking about? That this is not new stuff, right? Remote operations, like Chris mentioned, IoT. As a domain, we have a lot of lessons learned and a lot of strong thought leadership in the cyber community, and that cannot be overlooked. Same with strategy, CS, product engineering, go to market, everything. It needs to just evolve with this space, but be grounded in the expertise and domain that's there today.
Yeah, but the one shift I have seen is companies that we've been dealing with for years that we know to be very structured in their processes around security. I can't say they're relaxing them, but the speed at which they're moving seems to indicate that they may not be considering all their security risks of what they're doing around AI, or they're willing to take the risk just to keep the pace of innovation moving. So I do see, a somewhat difference in behavior. That's all I can say.
Okay, slightly scary, but okay. So and one more, which is very, very pertinent to our specific topic here. So from Nihir Joshi, what patterns do you recommend for tagging, normalizing, and versioning upstream telemetry and documents so they are compliance grade inputs for AI models, not just raw time series data? So anybody want to tackle that one? Or not? So basically, how to make things compliance grade.
Yeah, I think it'd be great to hear from Chris or Anthony. Neha is in my organization, so I'm not going to answer that. And I think it's a good opportunity. I feel like Chris was positioning Adlib and Vernova well to talk partnership. So maybe you guys can talk a little bit about that. That'd be great.
Yeah, I was just pulling it up over on the right. And so there's two elements that we primarily focus on. One is pre-processing and one is called post-processing. Think of like in the middle of pre and post are, in this instance, Vernova's core systems. So all of your AI apps and any large language models that you may be using. And so the pre-processing, a lot of what Anthony showed in the demo around standardizing file types, extracting with accuracy, providing confidence scores based on, say, multi-LLM voting, because some LLMs are better than at certain things than others. And so all of that is pre-processing, and that's to get the data, again, clean pipeline data ready to feed into the AI applications and models. And then the post-processing gets to more of the auditability and trust. So how can we link the outputs of that AI model back to the source record? And so that's where you would have like the data lineage. So the document sort of, chain of command, if you will, because as you can imagine, that pre-processing the data that, in this instance, Adlib is helping, say, Vernova out with around, say, a P&I document. Yes, we can control like the quality of all that documentation, but then it goes into one of your core systems and it get mixed with other data that's within that system. So coming out of your core system is what we had basically anointed as being accurate, along with data that was outside of our control. And then you get a mixed sort of output. Being able to sort of draw that back to a source of truth document, very important, especially when you can add like automated citations. So you can see exactly where that output is linked to a citation or a passage within the original document.
Okay, fantastic. Unfortunately, guys, we have run out of time now. So it just remains for me to say thank you very much to all of you for your insights, for your expertise, your knowledge. Thank you again, specifically, of course, to Adlib Software for sponsoring the session. Without you doing that, we wouldn't be able to run these events. So thank you again for that. Thank you to our audience as well for you and your great questions. For the ones we didn't get to, we will ensure that you get a response after the event. And it's now time to move on to the next session in today's event, which is the $12 trillion interconnect, solving the AI load crisis. So enjoy that one and enjoy the rest of the event. I'll see you again soon. Thank you, guys.